Let us consider some problems of integration we will solve with the help of partial fraction, and before that we will solve some problem by using by parts rule. Before starting the problems, let's see the product rule of differentiation. If f and g are differentiable functions, then the product derivative of this product can be written in this form. And from this we can deduce this rule for integration. And this formula can also be written in this form. We will implement this rule to solve some problems. Let's see an example, a question. We have to evaluate the integral of 6 tan inverse 8 by w with respect to w. We have to use the formula which is mentioned in the form of u and v, and we need u and dv from the integral, from the integrand. And from the integrand we take this whole value as u and dw as dv. From u we can find du, just taking the derivative, and we know that tan inverse of 1 over x, tan inverse of x is derivative of tan inverse of x is 1 over 1 plus x square. So this 6 is as it is, and tan inverse of 8 by w is 1 over 1 plus 8 by w square. But here we need the derivative of 8 by w as a product, which is minus 8 by w square dw. Or we can write it as from the other side, this is dv which is equal to dw. This implies that v is equal to w. These all values will be the requirement for the implementation of the formula 3. Now du is, after simplifying, we obtain is equal to minus 48 divided by w square plus 64, and this is the formula 3. We have all these four values. We have u and dv. Here it is u, and we have taken dw as dv, and we will write it u into v. V is equal to w was calculated in the last slide, while u is 6 tan inverse of 8 by w minus integral of v du, and du is here with the negative sign, which makes this sign as positive, minus 48 divided by W square plus 64, while V is W is equal to W. Hope you will understand. Now we are very close to our solution. We have just to evaluate this integral. And the integral has this value, while first part is given as 6w tan inverse of 8 by w, and this is the constant of integration. This is the solution of the first question. Let's move ahead. Trigonometric ratios are here. Tan cube of 6x, secant power 10 of 6x. This product is the integrand, and we are well aware of this identity that tan square theta plus 1 is equal to secant square theta always. We will use this identity. Tan square theta plus 1 is equal to secant square theta. Just we take tan square theta from here and write it as secant square theta minus 1. The tan 1 tan 6x is written here. Similarly, we take secant 6x power 9 here and 1 secant here. Now we select u, which is equal to secant of 6x, while derivative of u is written here. We know that secant theta, the derivative of secant theta is secant theta tan theta, but here is 6x, whose derivative is 6, which is multiplied here. Therefore, du is mentioned here. Now we replace u and du. We simplify in terms of u here. And manipulation yields this step, and we can easily calculate the integral in terms of u by using power rule. But we have to go back in next. We substitute back in for u and obtain this result. And the constant of integration is added here. Let's see another question, which is the product of two terms. Let's consider u as cos of 1 by 4z and dv as e raised power 2z dz. This u will give us du, and this dv gives us v. Just taking derivative, we obtain du, and integrating, we obtain v. We will use these four values in our formula to obtain the integral. And using the formula 3, we have uv, the product of uv here, minus u dv. This is exactly according to the formula which is discussed earlier. Simplifying, we obtain this result, but this result again involves the integral of the product of these two terms. Now we solve this second part as this integral part. We take u as sine of 1 by 4z and dv as e raised power 2z. We obtain du here, and from dv we obtain v. Now we replace it again in this right hand side, just replacing the value we obtain. This is again the same thing which we are going to evaluate, which is on the left hand side as mentioned here. Now it becomes more easy. We will shift this value on the left hand side. We name it as I, which is already here R, and on the we bring 1 by 64i on the left hand side, and we have no integral on the right hand side, and simplifying we obtain the integral value of the given question A. Let's evaluate this given question. This will be solved by using partial fraction. And we are well aware of about partial fraction, especially for the linear factors. It's very easy to split the question in terms of addition. We can write this denominator as the product of three terms. And using the partial fraction, we obtain this value. Using the rule of integration, we can separately evaluate these all, and integral of 1 over x is log of x, and similarly we obtain these two more results in terms of log, because the derivative of 3x is 3 is written here as a part of 18, and this 6 is outside the integral, and we obtain log of 3x plus 4. Hope you will understand.